In this section, we're testing the difference between two means or proportions. This example has data from New England and Rocky Mountain regions, and they're comparing crime rates. So the first thing to notice is that New England is designated as the first population, and Rocky Mountain is the second, or the first and the second sample, for example. So I've entered the information into list 1 and list 2 to easily calculate the mean and the standard deviations of the two. So you'll see that on the calculator here. List 1 and list 2 contain those values. To find the mean and the standard deviation of each, we need to run one variable statistics on list 1 first. The mean of list 1 is 3.53. And the standard deviation of list 1, notice the difference that this is S, so we want Sx for the sample. Standard deviation, not sigma x for the population standard deviation. This is not what we have. So the standard deviation of the sample is 0.828. To 2 decimal places, we'll go 83. We need the mean and the standard deviation of the second sample, so we'll run one variable statistics on the second list. Get a mean of 3.88. The level of significance is alpha equals 0.05 from here. And then we have to determine the null and alternative hypothesis. So we're trying to determine if the Rocky Mountain region has a higher crime rate than New England. And here it's important to tell the difference or distinguish between the first and the second population. Remember, the Rocky Mountain region was population number 2, or sample number 2, and New England was sample number 1. So what we really want to know is if the crime rate, the mean crime rate in population 2 is higher or greater than the mean crime rate in population 1. I should not use the equals because of course that's for the null hypothesis, so obviously the null hypothesis has the mean crime rates of both of them equal to each other. We can cross this one out. And then we want the second, or the Rocky Mountain region crime rate to be higher than New England. That's what we want to test. This is equivalent to the mean of New England being less than the mean crime rate of Rocky Mountain. So that's the alternative hypothesis, which is found right here. I think that this is going to be tricky for students to remember that the populations are already numbered for us and to identify who goes where. So this guy is the null and alternative hypothesis. The sampling distribution here is a student's t distribution. We don't have the population standard deviation. Those are unknown, and we assume that they are approximately normal. To calculate the value of the sample test statistic, we can do it by hand or use the calculator. To use the calculator, we want to run a test on 2 samples, and it will be a t-test since we do not have the population standard deviation. I already have the data entered in list 1 and list 2. The frequencies of both of those lists are 1, and the alternative hypothesis is that the mean of the first list is less than the mean of the second. So here I'll choose this value. We say that the variances are not pooled, and calculate. So I get a t-value of negative 0.932 to 2 decimal places, and a p-value 0.1812. The sampling distribution, we have a negative t-value, and we're looking to the left. It's a left-tailed test, so we have something like this. Negative t-value, left-tailed test. Then we have to make a decision. The level of significance is 0.05, but our p-value is higher than that. So this is a fail to reject conclusion. If we fail to reject, then the data that we have gathered is not statistically significant. To make an interpretation, we said we failed to reject, so we do not have sufficient evidence, or there's insufficient evidence that the violent crime is higher in Rocky Mountain than in New England. So let's check my tab, how it feels about my answers. I got a mean wrong. That is interesting. And the t-value. Now this would make sense if I have a problem in the list, so I get both the mean and the test statistic off a little bit. So let me check my list first. The problem seems to be with the first list, so 3.5, 3.9, but here is 3.6. Then 4.2, 3.7, 3.3, 4.1, 1.8. 4.8, 2.9, 3.1. So let me try it again. I need the mean of the first list. Take 2, get just 3.5, and then run the test against that test. 2 sample t-test. Information is in the list. The rest of the things are consistent from before. Get a t now of negative 1.017. The p-value is correct, which is a little surprising, but because we are not provided with the tables for all these, I think that MindTap has been programmed with a tolerance that's a little wider than we've seen previously, just to allow for some differences in interpreting this p-value. So let's check my revisions. I have the sample mean correct and the t-test statistic correct as well.